Hello, this is Dr. Christy Patton Lukes, a chemical engineering professor at Missouri S&T. In this lesson for engineering economics, we'll be looking at ways of forecasting uncertainty, and in this lesson, we'll be using sensitivity analysis. So again, as a reminder, we have three ways that we are looking at to quantify risks. The first was scenario analysis. In this lesson, we're looking at sensitivity analysis, and we will next be looking at probabilistic techniques. So sensitivity analysis says look at a variable. So we usually use net present value, maybe EAOC, perhaps rate of return, and choose that as your variable. And what we want to do is see how this variable is affected by one of the input variables or any combination of those. So for the case of net present value, I could look at how it changes with variable 1. Okay, maybe that was the fixed capital investment. And the derivative of the net present value with respect to, say, fixed capital investment would be the sensitivity to the fixed capital investment. Now we can approximate these derivatives using just changes, okay, over a small increment of fixed capital investment or whatever. And if I wish to look at this for multiple variables at one time, I simply am going to take the sensitivity times the change in that variable for all of the various combinations of variables that I want to consider at one time. This gets me an effective change to my net present value. So in this example they look at in the textbook, they are doing a sensitivity analysis for revenue, cost of manufacturing, and fixed capital investment. They do these computations, figuring out what the change is if they increase the revenue by 0.5%. And the change to the net present value, or the new net present value, is 18.17. If they decrease the revenue by 0.5%, the net present value is 16.07. The difference between those over that change from the original revenue to the final revenue that they selected gets us $2.8 million per year effect on the net present value. Cost of manufacturing, if you do a similar thing, comes up with a negative 2.8. And for a 0.5% up and a 0.5% down on fixed capital investment, that effect is going to decrease the net present value by $0.6 million per year. So things that you can see from this is, first of all, that the effect of a change in revenue or cost of manufacturing are very similar, okay, just opposite directions in that effect. And the fixed capital investment is a much smaller effect for a 0.5% change on that variable. If you combine these and look at these, one thing that people frequently do is they graph these, and they find where they are going to be comfortable with what the effect is. If you add them all up using the formula, we end up with this as our expression. And for this, when I do a 2% increase in revenue, along with a 3% increase in fixed capital investment, what we find is that the net present value change would be $1.5 million. So it would increase by $1.5 million. So I had a large increase in fixed capital investment, a smaller increase in revenue, yet the net present value overall went up. So this is an example of how to use sensitivity analysis. It is very good for analyzing specific cases that you might wish to study, but it is a little bit harder to determine how bad could it be, how good could it be. So we still have one last tool to consider, and we'll be looking at that in our next lesson. Thank you.